From this subject, we start with the new topic, that is different operations on Q. So, we start with what are the various operations on Q. In the figure 8.1, as we observed, front is equal to 0 and rear is equal to 5. Now in this case, we are inserting the data from rear position, deleting the data from front position. Now suppose we want to add another element with value 45. The rear would be incremented by 1. Understand? The rear side of the cube, as shown in the figure 8.2, incremented by 1, and the value would be stored at the position pointed by rear, and the value which is come new, that is stored at the position where the pointer points. In figure 8.2, front is equal to 0 and now the value of rear is changed from 5 to 6. Every time a new element has to be added from rear side. We repeat the same procedure for insertion of a data, inserting the data from the rear end. If we want to delete an element from the queue, then the value of a front will be incremented because we want to delete the data. So the value is incremented. Deletion are done from only this end of the queue, not from the other end. Deletion can be done only from the front. The queue after deletion will be shown in the figure 8.3. So this is the figures which represents a simple insertion from the rear end and simple deletion from the front end. As we delete the data, front is incremented, right? So this type of important concept of a queue is important. The questions can be asked for 2 marks or so, for 4 to 5 marks or so, because for the short question asking only for what is queue, what, just give the different names of the operations inside the queue, or for the long answer you have to explain the different operation with the figures, with the help of figures and the definition of a queue. In that definition you have to mention what is FIFO, which is very important inside the queue. As we perform different operations in a queue, in this case also we have to consider some conditions. Now what are these conditions? The first condition is the condition of overflow and the condition of underflow. Now what is this? Okay, so this is nothing but before we inserting an element in a queue, we have to check the conditions. Now in that case, first of all we have to consider what is overflow condition. An overflow will occur when we try to insert an element into a queue that is already full. Means, suppose the queue size is 6, okay, and we are inserting the sixth element. Now we want to insert the seventh element, but the queue is completely full. So in that case, we have to mention one condition, is that rear is equal to max minus 1, where max is a t. When rear is equal to max minus 1, where max is the size of the queue. Max means total size of the queue. If total size of the queue minus 1 condition is true, then it recognized as the overflow condition. Now when real is equal to max minus 1 gives an overflow condition, note that we have written max minus 1. Because why we are returning max minus 1? Because the index starts from 0. As we are considering the concept of linear arrays, array starting position is 0. As we are starting from 0, and that's why we are considering max minus 1 means overflow condition. Now the next is we have to consider the next condition, that is underflow condition. Now when the underflow condition occurs, it occurs when we try to delete an element from the queue where the queue is already empty. Means the queue has no element inside, and we are trying to delete the element from the queue. Now when it will be happen, when, or we can consider if front is equal to minus 1 and rear is also minus 1, it means there is no element in the queue. That's why we are writing as a minus 1, as it starts from 0. That's why we write all the time minus 1. Let us look at the figures 8.4 and 8.5, which shows the algorithm to insert and delete an element from a queue. So with the help of this, we understand insertion, deletion, as well as overflow and underflow. So let us look at the algorithm. So this is the algorithm consists of different steps, that is step 1, step 2, step 3 and step 4. What the figure name is? Algorithm to insert an element in a queue. Now whenever we are inserting the element, which conditions we have to consider? First condition we have to consider is rear is equal to max minus 1. Next, if front is equal to minus 1 and rear is equal to minus 1, then what we have to do? Or two conditions we have to consider. Now we line by line understand the steps which are included in this algorithm. Step 1. We first check for the overflow condition. Okay. Now in step 2, we check if the queue is empty. In case the queue is empty, then both front and rear are set to 0, so that the new value can be stored at 0th location. Suppose queue is empty and we just want to use that element or use that queue as the queue is empty. So we are setting front and rear is equal to 0. Otherwise, if the queue already has some value, then rear is incremented. Then what? Yes, then this rear is incremented so that it points to the next location in the array. If the queue is empty, then it is the responsibility that rear should be incremented so that we can insert the data. In step 3, the value is stored in the queue at the location pointed by rear, because rear is incremented, so whatever the pointer it points in that location, we are storing the new value. So this is the pattern, this is the algorithm that we have to follow to inserting a new element inside a queue. And this algorithm helps to design a program to insert the element inside the queue. Now next is figure 8.5 shows the algorithm to delete an element from a queue. In step 1, we check for an underflow condition. Now how we check the underflow condition? If in step 1 we write if front is equal to -1 or front is greater than rear, then write underflow. However, if Q has some value, then front is incremented. So we go to the else part so that it now puts to the next value in the queue. So we go to the else part and we write there set val is equal to Q of front, and we are incrementing the front by 1. So we have checked both conditions. First is underflow. If it is an underflow, then exit. No, if it is not, then front is incremented by 1. So this is the algorithm to delete an element from the queue. So with the help of this also we can design the program to delete an element from the queue. Thank you.